Assalamualaikum and good afternoon. We are from group IMTIAZ. These are our member, NABILAH, Muhammad LOQMAN Hakim, Muhammad Khairul and me, Muhammad IZZAD. What is nozzle and diffuser? Nozzle is a device that increases velocity and decreasing the pressure. There are two types of nozzle. First, conversion nozzle. Second, conversion diversion nozzle. Okay, so what is diffuser? Diffuser is a device that decreases the velocity and increasing the pressure. Application of nozzle: gas turbine, steam turbine, jet engine. Application of diffuser: centrifugal compressor, ramjet engine. Okay, next we go to the question. The question is: steam enter a nozzle at 40 bar, 400 degrees Celsius, and with a velocity of 10 meters per second steadily. The steam exists at 40 bar and with a velocity of 665 meters per second. The flow rate of the steam is 2 kg per second. Heat transfer and change in potential energy can be neglected. Determine the cross-sectional area of the outlet opening in meter square. Okay, first we need to list down all the information given. By referring the table A6, we can get the T at 4 MPa, 250.35 degrees Celsius, and the H is 3214.5. The H1 is 3214.5 kg per kg. H2, how to calculate H2? H2 is 3214.5 kg per kg plus 10 square minus 665 square divided by 2 times 1000. The answer is 2,993.435 kg per kg. Okay, next. At 14 bar, Hg 2,788.9 kg per kg. Okay, you can see this table A5 at pressure 1400 kPa. The Hg is 2,788.9. H2 less than Hg. That means this condition is superheated steam. How do we find volume? V2 by using interpolation. So we need to look at what we get, 2,993.44. This answer is between 2,927.2 and 3,040.9. So by referring the table, you can use interpolation by taking their H and their V. So the V2 is 2,993.435 minus 2,927.5 divided by 3040.9 minus 2927.5 multiplied by 0.1823 minus 0.16356 plus 0.1634. The answer is 0.1743 meter cube per kg. How to find area? The area is 0.1743 multiplied by 2 divided by the velocity 665. The answer is 5.24 times 10 to the power of negative 4 meter square. Okay, that's all. Thank you.
Hi, my name is Khairul bin Faris. My matrix number CD190085. So I will explain about throttling valve. So, what is throttling valve? Throttling valve is a type of valve that can be used to stop, start, and regulate the flow rate of gas or fluid through in the pipe system. So from that, we know the flow rate depends on the opening and closing stage valve. Next, what type of valve that we have? So in this slide shows the most valve are used in industry. First, we have loop valve, butterfly valve, gate valve, diaphragm valve, needle valve, and hinge valve. Next, how we choose the valve? We can choose the valve, follow their characteristics such as valve size, material of construction, actuation, connection, and industry standards. Next, where can we find the application of this valve, throttling valve? So, we can see the application at refrigeration, air conditioning system, fuel oil system, and food processing application.
Now, let's see the example. Refrigerant 134A enters the capillary tube of a refrigerator as saturated liquid at 0.8 MPa and throttled to a pressure of 0.12 MPa. Determine the quality of refrigerant at the final state and temperature drop during process. T2 equal to T saturated at 0.8 MPa. You can see in this table 31.31 degrees Celsius. Then H1 equal to HF at 0.8 MPa. You can see in this table 95.47 kilojoule per kg. Then we go to P2 is equal to 0.1 MPa. So for this, H2 equal to H1. T set at 0.12 MPa. You can see in this. So it will negative 22.32 degrees Celsius. So for HF equal to 22.47, for HG 236.99. Both of this is kilojoule per kg. this value we got from the table. Then we go to first, that is quality. So to get the quality, x2 equal to h2 minus hf per hfg. So hfg we got from the table is 214.52 kilojoule per kg. Then x2 equal to h2 we get 95.48 minus by hf that we get, that is 22.47 kilojoule per kg divided by hfg 214.52. So after we use the calculator, we got the answer is 0.340. This is answer for the quality. Next, we calculate for the B. There is the temperature drop. So T2 equal to T saturated at P2. So T2 is equal to negative 22.32 degrees Celsius. Okay, then temperature drop is equal to T2 minus T1. So T2 we got, that is negative 22.32 degrees Celsius. Then we minus with T1. For T1, oh, I'm so sorry, this is my mistake. So T1 is 31.31 degrees Celsius. Then we got the answer, that is negative 53.63 degrees Celsius. So this is the answer for the temperature drop.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad LOQMAN Hakim bin Hanidam, nombor metrik AD190099. Dan hari ini saya akan menerangkan serba sedikit mengenai heat exchangers dan contoh-contoh problem dan solution. Okay, what is heat exchangers? Heat exchangers are devices designed to transfer heat between two or more fluids, liquids, vapors, or gases of different temperature, depending on the type of heat exchanger employed. The heat transferring process can be gas to gas, liquid to gas, liquid to liquid, and occur through a solid separator which prevents mixing of the fluids or direct fluid contact. Next are the design characteristics, including construction, materials and components, heat transfer mechanism, and flow configurations. Also help to classify and categorize the types of heat exchanger available. Finding application across a wide range of industries, a diverse selection of these heat exchanging devices are designed and manufactured for use in both heating and cooling processes. Now, let's do some problem and solution. Okay, what we get here? A concrete counter current heat exchanger is used to cool lubricating oil. Water is used as the coolant. The inlet and outlet temperatures are given in the table. Okay, let's see. The mass flow rate of oil into the heat exchanger is 0.1. What is the mass flow rate of water needed to maintain these operating conditions? Okay, let's see the solution. Okay, first step yang kita nak buat ialah kita lukis dulu. Kita lukis dulu bentuk. Kita ada temperature in untuk oil, iaitu kita ada temperature out untuk water, dan kita ada T in untuk water, dan untuk keluar T out untuk oil. Okay, so mass flow rate untuk oil ialah 0.1 kg per second, dan untuk mass flow rate untuk water yang kita nak cari, okay, dan okay, next step ialah kita guna formula. Untuk problem ni kita akan guna formula mass flow rate oil times heat capacity oil times temperature in for oil minus temperature out for oil equals to mass flow rate for water times heat capacity for water times temperature out of water minus temperature in of water. So kita dapat semua ni. Heat capacity for oil kita dapat 2131. So heat capacity for water is 4178. Assuming that constant heat capacities for both fluids. So next, so kita pindahkan next kita akan pindahkan dan kita akan dapat mass flow rate for water equals to mass flow rate for oil times heat capacity for oil times temperature in for oil minus temperature out for oil divided by heat capacity for water times temperature out for water minus temperature in for water. So kita akan masukkan dapat 0.1 darab 2131 darab 45 bahagi 4178 darab 7. So answer yang kita dapat ialah 0.33 kg second per second. Okay, so inilah solution untuk problem tadi.
Hello, now we're going to look at pipe and duct flow. So what are pipe and duct flow? It's basically a transportation that are used to transfer fluid from one device to another device, and the fluid usually satisfied with steady state, or we can call it as a steady flow process. So what are the difference between pipe and duct? So pipe has a circular cross-section, while ducting has a rectangular cross-section. And pipe can withstand a higher pressure differential, while ducting only can withstand with lower pressure differential. So fluid that usually using as piping system is water, oil, and any chemical substance that are in liquid. So for ducting, usually fluid that usually use ducting system is air, gases, or any substance that are in gaseous form. So we look where the application use piping and ducting system. So for piping system, usually it is cooling water system, drain or sanitary water system, chemical process plant. So these are the example for piping system. And for ducting system, we usually see HVAC system. So this is ducting. HVAC system, heat ventilation air conditioning system, and furnace vent, also gas and condenser. Now we're going to look at the question. So example here, we have a refrigerant 134A, or this is the gases, flow through a pipe and the gases are heat. Supplied with heat. So these are the figure. So the question asks to identify the volume flow rate, mass flow rate, and velocity at the outlet or at the exit here. Now we look at the solution. So the good thing is we have pressure and temperature at the inlet and the outlet. So from this pressure and temperature, we can identify other properties using steam table. So we have here is the row for specific volume, internal energy, entropy, and enthalpy. So there are the information or the other properties. So first question asks about the volume flow rate. So volume flow rate is Q equal to AV, or some other book use a V dot to represent the volume flow rate. V dot and Q are the same, so we can use this formula also, which is area times velocity. And for mass flow rate, represent with m dot equal to 1 over specific volume times area times velocity. So how we want to find the volume flow rate? With the formula V dot or Q equal to A area times velocity, we find the area first, we input the velocity with 5 meters per second, and we get the answer 0.3079 m cubed per second. Now we look at the m dot is equal to 1 over specific volume times area times velocity. We find the area, we find the specific volume, we input the velocity, which is 5 meters per second. Now we get the answer for mass flow rate is 2.696 kg per second. And the final answer asks about the velocity at the outlet. So first we're gonna identify the volume flow rate at the outlet first. Okay, from the volume flow rate, we can use this formula to find a velocity or final velocity at the outlet. So first, how to find the velocity, the volume flow rate? So volume flow rate also is m dot times specific volume at the outlet, V2, because we want to find the specific volume flow rate at the outlet, right? So we use a specific volume at the outlet to find the flow rate. So we get 0.3705 m cubed per square, and from the volume flow rate, from the volume flow rate, we can use the formula area times velocity to find the answer for velocity at the outlet, and the answer is 6.02 meter per second. It's easy.